All right, question 8. Triangle ABC has the vertices at A, 5, 2, B, -3, 1, and C, -2, 5. Point D is located on the intersection of the altitude and segment AB in such a way that D has the coordinates at approximately -1.52, 1.18. Match each question with the correct measurement rounded to 1 decimal place. What is the approximate length of the base of the triangle for the given altitude? Okay, so remember that the altitude is the height of the triangle, so it's our perpendicular line. So the altitude would be DC. Now it wants our base, so that's the side that altitude hits. So the side that our altitude hits is BA. So I'm going to use my tools, and I'm going to just search distance formula calculator and see if something comes up. Math Warehouse has a distance formula, and so I'm going to type in the coordinates for points B and point A and find it. So point B is at -3, 1, and point A is at 5, 2. You could have also entered them the opposite. It will work out to be the same. It's 8.0622. So BA is equal to 8.0622. So rounded to 1 decimal place, this would be 8.1 units. What is the approximate length of the altitude of the triangle? Okay, so the altitude of the triangle is from point C to point D. So in our distance formula calculator, point C is at -2, 5, and point D is located at -1.52, -1.52, and 1.18. That's to calculate it, so it's 3.8500. So from C to D, that's equal to 3.8500. So rounded to the nearest tenth, which is our first decimal place, this 5 will round that 8 up to a 9. So this will be 3.9 units. Now they want to know what is the approximate area of the triangle. The area of a triangle is equal to 1/2 base, 1/2 times its base times its height. Now we figured out what its base was. It is 8.0622. And its height is the altitude, so that's 3.8500. So we would type in our regular calculator, we would type in 1/2 times 8.1 times 3.9. That's the approximate. So this 15.79, that 9 would round that 7 up to an 8. So 15.8 units.